Good day, good day, good day, everybody. And once again, we're back together. Right, so we're looking at question 4 from our technical science question paper. This is November 2024. So please, if you haven't subscribed, just make sure you're part of the family. And please don't forget, we've got memberships as well, where you can get some really carbo-loaded content. All right, so for those of you who need some extra stuff. All right, let's get into the question. So they say to us, we've got an airport worker that needs to transport a passenger bag of mass 30 kilograms to the aircraft. He decides to load the bag onto a trolley of mass 10 kilograms, okay, and then pulls the handle of the trolley using a 50 kilogram, or rather 50 Newton, a force of 50 newtons at an angle of 30 degrees to the ground. Okay, so I just need to make sure that I remember that our trolley is 10 kilograms. Hey, it's easy to forget those things. So that's 10 kilograms there. Okay, right. So now they say to us the trolley experiences a frictional force of 50 newtons. Okay, so we know we've got 50 newtons acting opposing the trolley. Okay, there we go. Right, and the bag is transported over a distance of 30 meters. All right, that's indicated there. Okay, all right, from the loading zone to the aircraft. So they say to us, draw a labeled free body diagram showing all forces, showing all the horizontal forces on the trolley. Now, they said all horizontal forces. Ne? Okay, right. Now, which are the horizontal forces that are acting in this case? So here it is. Firstly, we know we'll have friction, right? So that's a clear one. So that's going to be frictional force. And secondly, which other one do we have? Now remember that we've got an applied force that is at an angle, but that's not a horizontal force. But what is? What is a horizontal force is the component, okay? So that's the horizontal component of this force. All right, so I'm going to remove this guy and say, well, this is going to be the horizontal component. We can call it Fx, but what Fx is F horizontal. Okay, component. Right, so that's the horizontal component of our applied force. All right, so those are the two forces that are acting. And please remember, ladies and gents, that when you are given a mark allocation, it's an indicator of how many marks, or rather how many forces, especially, I mean, when you are drawing a free body diagram, it indicates to you how many forces there are in that diagram. Now they say to us, calculate the work done by the applied force on the trolley. Okay, right, so this is going to be quite straightforward. So we want to find out what is the work done by the applied force. Now, there are two ways in which I could do this, right? I could find what that horizontal component is, right? And say, well, the work done would be the horizontal component of the work done, of the force, of the applied force, multiplied by the distance, right, that we have there. Alternatively, what I could do is I could use the principle work done, that's force multiplied by the displacement, the cos of angle theta. And I'll show you what I mean by both in this case. So firstly, how do I find the horizontal component? Well, I know that my applied force is 50 newtons. It's acting at an angle of 30 degrees, right? And I'm looking for this guy for the adjacent side, right? So that means that the horizontal component will be 50 multiplied by the cos of 30. Okay, so I'll leave it just like that, right? So then what I'll do is to say, well, work done. As I said, that's F horizontal multiplied by the displacement or the distance. So that's 50 cos of 30 multiplied by the distance, which is 30 meters. And that would give us the final answer, right? So that's 50 cos of 30 multiplied by 30. And that gives us 1,000, well, let's say 1,300. So I'll say this is 1,300 newtons. Okay, I mean, sorry, it's 1,300 joules, right? Okay, alternatively, I said we could use that formula and say, well, what was the magnitude of the force? That's 50 multiplied by 30, the cos of the angle. Now remember, guys, that when we're using this formula, the angle is the angle between the direction of motion and where are we going? We're going in that direction, and the force in question. And the force that we have is the applied force. In that case, it's acting at 30 degrees to the horizontal. And so that would be 50 multiplied by 30, cos of 30, and that would still give us 1,300. Look at me saying newtons again. Joules, right? So remember, work done is energy, right? And that would be in joules. Ladies and gents, I'm going to leave this here because the next question is a separate question. So I'd love to treat them as two different questions. So let's look at it at our next video. Right, for now, I'll see you guys again next time. And it's sharp from me.